This Bluetooth shifter works perfectly with an open SIM wheel because it eliminates the USB cord and makes the platform wiring a lot neater. It's an enjoyable and satisfying project to make yourself. The downsides are that the battery has to be charged every 30 to 40 hours, and there is a short 10 to 15 millisecond delay from pushing the button to it being registered by the PC. The project I am about to share and the files needed came from this site. I will put all the links in this video in the description. The project is essentially two Arduinos talking to each other over Bluetooth. The Arduinos are both Teensy version 3.2s. The Teensy is a type of Arduino Leonardo, but about a fifth of the size, and appears to the computer as a joystick. Teensys are very useful for simulators, however they are a lot more expensive than a Leonardo. The Teensy on the wheel runs at a very low frequency of 16 MHz, with some board features completely turned off, like the USB interface. This allows it to run on a 3.7 volt LiPo battery with very low power consumption. The Teensy connected to the PC, or the base unit, appears like a joystick and passes the button presses from the wheel it receives over the Bluetooth to the PC. The wheel also monitors the battery charge level and will indicate on a LED on the base unit when the battery has reached the lower limit and needs charging. When buying the battery, you will also need a charger. Don't buy one that puts out 3.7 volts, they don't work. You need a $4 smart charger like the one I will share in the materials list shortly. It puts out 4.2 volts and indicates when the LiPo is charged. The onboard LED changes from red to green. The goal is to avoid using the battery below 3.7 volts, as it will shorten the life considerably if you enter into the lower 20% of its capacity. The 3D files are straightforward and easy to print. The paddles can be cut from acrylic or can be 3D printed as well. I was lucky to have access to a laser cutter, so some parts were cut out of 3mm acrylic. The shifters have a magnetic return. The low-cost magnets have a very clear tactile and audible feedback that the shifter has been activated. The project is quite customizable and mounts easily on an OSW steering wheel. For my project, I used 8 programmable push buttons and 2 shifters. The Bluetooth modules from eBay did not behave exactly like those described in the original project and the accompanying software. I suppose there are different versions of the HC05 around, so check out the one that I used and match it to the one that you buy. In addition, the Thingiverse project did not give enough detail about wiring the whole project. So in this video I'll share with you the schematic, how to pair the Bluetooth modules, connect the Teensy to the Bluetooth modules, and the mods needed to make the code work for you. You're going to need the 3D printed parts from here. You're going to need 4 round rare earth magnets, the 8mm size, 8 mini round push button switches, a lithium battery charger, the TP4056. Just remember, don't buy one of these. You're going to need a 3.7 volt 1000 milliamp hour rechargeable LiPo battery. You're going to need 2 HC05 Bluetooth modules. Don't get the HC06 modules because they can't be programmed with AT commands, and so you can't connect them to each other. You're going to need 2 genuine Teensy 3.2 development boards. Now these are $40 each. I bought them from a local stockist just to make sure that they were genuine. You're going to need 2 micro switches, and then you're going to need some various bits and pieces. A couple of LEDs for the base unit, some 82 ohm resistors to limit their current. You're going to need a 10K and a 3K 3 ohm resistors for the battery charge measurement. You're going to need a couple of 1K ohm and a couple of 2K ohm resistors for the voltage division, connecting the Arduinos to the HC05s, and you're going to need some bolts and some hookup wire. The next thing you're going to need is the software. The Arduino can be downloaded from here. This is the Arduino IDE. The Teensy website is here. The direct link to the Teensies, if you want to go and buy them directly from the store. You're going to need some additional libraries for the Arduino IDE so that the Teensy can be put into the correct mode. And you're going to need the actual code for the wheel and base. Now, there are a lot of videos on YouTube showing how to install the software and use the Arduino IDE, and this is an example. While I was printing the 3D parts, I paired the two Bluetooth modules together and made sure that they worked. Now, the best explanation I've seen for this pairing is here. Now, I used an Arduino Nano and it worked fine for setting up the modules. So here is my test setup. So note how pin 0 of the Nano goes to the HC05 through a resistive voltage divider. In this photo, the orange wire is connected to pin 0 on the Nano. This pin on the Nano is labelled RX or receive. The orange wire goes through a resistor divider over 1K and a 2K2 to the receive pin on the HC05. Pin 1, labelled TX or transmit on the PC board on the Nano, goes to the TX pin on the HC05. No divider is needed because the signal being sent to the input pin on the Nano is quite happy with the levels being received. Note that even though the wheel HC05 is being driven by a 3.7 volt LiPo battery, when fully charged it's 4.2 volts. The Teensy therefore will send signals at that voltage to the HC05, which is more than the maximum voltage recommended. You'll find lots of videos on YouTube and tutorials on the internet that say that the HC05 works fine at 5 volts. Well, maybe it does for a while, but for the sake of a couple of 1 cent resistors and a few extra minutes of soldering, your modules will last for a long time. And if something does go wrong in the future, at least you won't be wondering if it's due to over voltage. To configure the Bluetooth modules, you'll need to get them into AT mode. On my version, all I needed to do was hold the small button down on the HC05 while I powered it on. I didn't need to connect any other wires. So the steps for setting up the modules are: connect the 4 wires between the Arduino and the HC05, upload a blank sketch to the Arduino and open up the serial monitor, making sure that the baud rate is set to 38K, test that the AT command works, check that it is in slave mode, get the Bluetooth address. Now you'll need to edit the address to swap the colons and the commas. Plug in the other HC05 module and get it into AT command mode. Set the module to master, set the connection mode to unique, and set the address for the module to connect to using the bind command. Make sure you mark the modules slave and master. I made the base unit first as it was easy to wire up. I used the following sketch to check that the Teensy was configured correctly and working. It simulates a button being pressed and released every second. Open up your joystick control panel and you should see the button being pressed and released in the properties window. Once I'd verified that it was working, I uploaded the proper base sketch with the following modification to eliminate the monitoring of the Bluetooth status pin. Now I moved on to the wheel assembly. Now, if you don't have a digital multimeter, simply use the 10K and 3K divider suggested in the Thingiverse article and stick with the default value of 3600 as the wheel software in this software sketch line. I only had a 12K and a 4K7 in my spare parts box, so my value when rounded up was 3700. To check that it was going to work, I rigged up a potentiometer and verified that the low voltage was being detected and sent to the base unit. The wheel teensy was configured in the Arduino IDE like this. The modifications I made to the code are: I used reasonably thin hookup wire and didn't worry about colours. I worked methodically around from right to left and wired the buttons directly to the teensy PCB. This eliminated any potential problems with DuPont connectors falling off. I looped a ground or 0 volt wire around to every button. You can see this wire at the top of the assembly. Each button should be wired to one pin on the teensy, and I use pins 3 to 12. I didn't complicate matters on the wheel assembly with more LEDs for the power and low battery indicators. Instead, I relied on the LED on the base unit to indicate low battery. Now, as for pairing indication, you can see the HC05 LED on the wheel assembly showing that the familiar pairing pattern, which is 2 short flashes followed by a pause when you first turn it on. The LEDs also use up valuable power from the battery. I'm using a teensy clock frequency of 16 MHz with no USB mode, and it seems to work fine. With a lower than stock teensy clock speed, this setup works easily for more than 24 hours continuously with the 1000 mAh battery. Well, I hope that's given you enough information to make your own Wi-Fi shifter. I found it an enjoyable project to make, and I hope you do too. Bye for now.